Hi everyone, welcome to our YouTube channel, Becoming a ROS Developer here at The Construct. My name is Rodrigo, and today we have with us Kirill, who's going to show us his project for ROS Basics in 5 days for Python. And he's going to show what he did with the basics of ROS, that is using topics, publishers, and subscribers, as well as services and actions, in order to control our Turtlebot here at the construct. So without further ado, hi Kirill, how are you?
Hey, yeah, not too bad. How are you?
Good, good. We're excited to see what you want, your project. So whenever you want, you can share your screen and get started.
Yeah, awesome. Um, Looks like the screen share is disabled at the moment.
Oh, let me enable it really quickly. There you go. You should be able to now.
All right, can you see that all right?
Yes, yes, we can see it. I can see that you're already connected to the robot.
Yep, so it all looks like it's just hanging out in the corner there. I might just drive it out of the corner so that it can do its thing. So maybe what I can do is just show the final, I guess, implementation, and then we can just walk and discuss the
Yeah,
bits and
exactly.
pieces that.
So show us, and then we'll go into how you did each part of what the robot is doing.
All right, let me just have a look. Turtlebot 3 move. Launch file is main.launch. Why is it not
You
finding?
missed an
Oh,
N
I
there.
mistyped it.
Yeah.
There we go. Uh, there we go. Yeah, so in terms of the setup, it sets up the servers for the different bits and pieces and then calls the client. And so it starts recording the odometry and then moving in a square. But I've just realized that I've put it in a bit of a funky configuration. So it's probably going to hit the wall and hopefully stop, maybe not.
Okay, so in that case, um, you have to make sure it's. Do you have any ways to detect if during the service there's an obstacle?
Yeah, so if we look at the setup.
If you launch it again, I bet it'll do it with the orientation that it is now.
Yeah, it looks like it's in a bit of a better position. Yeah, so I think there it spotted an obstacle somewhere. Oh, no, sorry, that's reverse. There's a little bit of delay with me like sending the command and actually seeing it move. Yep. All right, let's try again.
So right now you're implementing it with a service and an action. Where is the like what does the service do? And, well, I guess we'll go into this in a little bit. While
Yeah. So once it turns around and gets
Mm-hmm.
back to stop, then we can have a look. Where's can you see the visual code stuff? I might just
Yes, I can
minimize
see
this
it.
a
I can
little.
see it.
Yeah, so basically the way I did it was I've set up like a single class for the robot
Mm-hmm.
and then implemented the different functionality inside that class. So it might be easier to just talk about it from sort of start to finish. But initially, like before I even looked at the action server, I sort of thought that I needed to use the odometry to essentially for the robot to function. So in doing the first couple of stages of the project, I set up some subscribers to the laser scanner and the odometry topics. So that's kind of available from the once that class is initialized. So if we look at the kind of elements of the moving in the square and recording the odometry action server. So what I've done is in the launch file, first it calls the odometry server and the square server, and then it starts to move around in the square and recording odometry. And so if we look at the callbacks, so first looking at the moving in the square callback, so essentially publishing the velocity to move forward and doing 4 turns, where a turn is made up of moving forward or rotating 90 degrees. And so in moving forward, I was looking at the distance. So from like the initial point, you would see how much you move forward and essentially keep going to complete the, I can't remember what it was exactly, 150 or 15 centimeters. And then in terms of turning, I actually had that set up as kind of like a hard-coded value, which could be improved by actually getting the like rotational data. But instead, I sort of did it through testing, where the angular velocity would publish for a certain value, yeah, for a certain amount of time. And so I would do that 4 times, and that's kind of the code for drawing the square. And the thing that we looked at before, which seems to be not behaving too nicely, is like looking for the collision in front.
Mm-hmm.
So with the laser scanner giving a whole bunch of data, I tried some different stuff, like, and maybe I mistyped the midpoint, which I think was at 90. Yeah, I think there was at 180 readings in total, and I thought 90 was bang in the middle. But I tried to do like a cone as well, where it would take, let's say, 80 to 100. And there I found that it would often catch an obstacle in its, I guess, as the cone fanned out. So I went back to just having the singular value in front and checking whether that whether that value was less than the side of the square length, so you could still sort of fit the right angle turn in that gap.
Right.
But looking at the performance there, it didn't seem to be working, to be honest. But that was kind of my logic in terms of setting that up. And if there was that obstacle, it would just send a 0 velocity command to the robot, and then essentially end this the move square function. Yeah, so in terms of the client, I mean, it's pretty straightforward. It just essentially calls the robot to do that. And then when we have the odometry recording, so I think a lot of the stuff with the actions I found quite confusing, like or really I had a bunch of issues with trying to set up the actions in terms of getting the functions to compile and, you know, be available through the from the message folder for the class to import. But once I got through that, yeah, it's sort of like there's a lot of structure to how to set it up, which I guess isn't that straightforward,
Yeah,
or at least that's how I found it.
You said you had a lot of problems during compilation and sourcing and finding packages. Is that?
Yeah, so you know how updating the CMake lists and the
Yes,
package and putting it, I think I might have put the action message into the messages folder originally, and that was throwing me off. But yeah, got it all working in the end in terms of getting all those message types available, and where's the, so the travel distance and the completion, so the travel distance was the feedback, and then at the end it would give you the,
you see the total, right?
Total distance, yeah. So basically what I did with this action routine was checking how much the odometry was changing between like consecutive iterations of the loop. And so if the odometry stopped changing, that was the indicator that the robot has stopped moving. And so that was the total, that was the time to end the total distance calculation, and send through the message saying that the recording has stopped, or like completed recording the odometry.
And it would stop because your service call would be completed, right? Or how would it know? It's like where does it stop the robot, like that, so that the actual client can tell, okay, I'm done.
Yeah, so basically the way I have it set up at the moment is during operation, it's always recording odometry. And then in the action, so like it's moving. And so after it finishes drawing the square, the odometry, the change in odometry stops, and that's the indicator for the action server to stop.
Oh, I see.
When I was thinking about this morning, in my head, it almost makes more sense to do it the other way, where the action, okay, so like if we have the move square as an action and have the odometry as the service, so then the move square could run and then send a message to the odometry to stop when it's complete. Because I think, yeah, basically what I've done here, I don't think that the communication is like it's almost like I have an extra step, right, in terms of measuring the odometry change. But instead it could just send a message once the square drawing has completed to the last stage or the last point.
That's interesting. And in this way, what would you use as the action feedback if you're using it to move the robot?
So what I thought is,
use it.
So what I thought is having the like the flag, I can't quite remember what it's called, but the flag of the action server to say the action is still running, so keep recording odometry. And then in the odometry code, you could just have the like warning or log, like whatever log type you want, saying like keeping that total. So instead of it being the feedback, it would just be a message sent to the either published or like just sent to the log.
Right, right. Oh, that's interesting. So in this script right here, is this where you're calling everything, where you have your action server and everything, or have you separated them into?
So I've just so initially when I was testing the different bits and
That's because
pieces,
I
I
see
was
a lot of files there, so I was wondering.
so initially I was doing like part by part. So here we just have the turtle robot, which is that class that I was talking about. And then once you initialize the class, you can execute the routine, which here was driving forward. I think the first part of the test was just looking to get the odometry data and just publish, print it or something like that. And then for the second part, that was the moving in a square. So again, here I had the robot class, which had the different servers and clients. And so it was calling these different routines. And then part 3, I think part 3, I was more just testing out the recording odometry as opposed to the moving in a square. And
But
so in the launch,
you don't use these parts, right? In your final
no,
one, you use the
no, no.
client and the server that I see there, I think.
Yes. So
Okay.
basically it's just odometry server and all the clients. So these 4. So it does the individual action basically, whether it's starting the clients or the servers, and there's these 4 that all get called by the launch file, but not the parts and this initial my robot, which I was just playing around with.
Okay, I see. And the main launch will includes all those. Is that what it is? Yeah. Okay.
Yeah, exactly.
Nice. Well, I think we have got the gist of it, don't you think?
Yeah, absolutely. I think I've had a few issues with the running the real robot lab sometimes as well. And like you said in the docs, like it all works in simulation, and then once you jump to the real thing, there's always some little things that don't work too nicely.
Yeah,
Um,
there's always that, and also hardware issues. We were going to have this presentation a couple of days ago, but we had some hardware issues that we had to fix. So yeah, there's always a big jump between the simulation and the real environment, and that's
yeah,
what we
absolutely.
are trying to emphasize here. And what I'm suspecting, so are you done? You're done presenting the scripts, right?
Yeah, yeah,
Okay, so could you stop sharing your screen so we can see it?
yeah.
All right, so I think we are okay. Good. So yeah, what I was saying is that um, that's what we try to illustrate with our lab here, and I'm suspecting that issue for the obstacle is I thought that was first of all, congratulations. It's a good project, and you look like you know you're talking about it. So that means you learned from the course. So
That's the secret,
congratulations.
right?
Yeah. So what I was saying is that I thought that was a really good idea for obstacle detection. That cone implementation sort of that you made, but and I suspect that what happened there, because it looked like it was detecting an obstacle when there wasn't one. So I think the orientation there was the issue. So maybe that's one thing to improve to how to make sure the you're going to be looking at the front of the obstacle, and that made me question. That made me want to ask you. So when you're running this the action server, does it consider the when it what would it do if there's a obstacle detection? Because the action server is just looking at the odometry. Is there a way that you implemented to consider like what happens when there's a collision, when there's an obstacle,
So,
I guess.
so basically with the current structure, like when the obstacle is detected, the move square server stops.
Mm.
So the robot stops moving. And so in the action code, it notices that there's no delta in
In
odometry.
odometry.
And
Yeah.
so it stops and says, total trip was X millimeters.
Right. That's what I was trying to get at. Because normally, if you don't, that's a really good way to set it up, because otherwise the action would fail. So in this case,
Mm.
the action is getting through, and you can do things with your result moving forward. So I thought that was also really nice, because I see a lot of times that if there's an obstacle, just the action fails. And I mean, sure, you can work with that, but it would be better if you take a successful action and keep working with it for whatever application you need. And that kind of is a way
Yeah,
of obstacle avoidance already.
I think in general, like it's pretty freeform as well. And like I was saying before, even just thinking about it this morning, I was thinking that maybe swapping the action and the client and the service between the square and the odometry could also be like a different implementation. But I think the gap with me is that I didn't really get as much opportunity to test the edge cases
Right. Yeah.
on the real robot. So yeah, that's why the essential mistake of shooting the collision laser at like, I don't know, 19 degrees off from forward or something like that has occurred.
Yeah. There's so many ways to sort of do the same application. We d- we specify it in the project, just so they know what to do. Otherwise, there would be like a lot of questions regarding that. But yeah, you're right. That's an interesting point that maybe we can um, sort of foment creativity in that way, so we can see how people think about it. And I thought it was really interesting that you mentioned that, because it shows that there's many ways to solve the same problem, especially in
Yeah,
robotics.
exactly. I guess having less direction then makes it a bit confusing if you're a bit stuck. But once you sort of get to the end, you think of like better ways of doing it, which is
Exactly.
the case
Yeah.
always.
Yeah. Well, that's I think that's all from us. So congratulations again, Kirill, and I hope you can continue your learning for ROS here, and we can keep helping you out to learn. And for everyone else that's watching, you can take our course and present here, so you can showcase what you've learned during the course, and learn ROS together. So thank you so much, Kirill, and I appreciate it.
Awesome. Thanks a lot.
Thank you. All right, everyone.
I'll
I'll see you later. Bye bye.
see you later.
All right. Nice.